Inspiring contractors to deliver exceptional craftsmanship with proven results. This is the High Performance HVAC podcast by the National Comfort Institute.
What's going on, folks? This is Casey with the High Performance HVAC podcast, and we've got my co-host here. Mark, why don't you introduce yourself?
Hi, I'm Mark Hunt. I'm a NCI instructor. Get to hang out today with the mighty Casey Contreras in lovely Arizona, and we have a guest of honor. I'll let Casey do that.
Oh yeah, the very, very famous Jim
Infamous.
Davis. What's going on, Jim?
Well, I'm sure I'm as famous as Buffering. So I'll just trying to keep it going. It's elsewise it's could be better, but I'm still winging it and getting some stuff down in writing. So I'm happy we can do this podcast and share some of my weird situations with more people. And today we're going to be talking about corrosion, how everybody wants to blame corrosion on anything but what it is. And I got plenty of unique stories here that the different applications. It shows when we go from a furnace to a unit heater to a big industrial boiler to a indirect fired makeup air heater, and then we got another furnace. Is that all of them? And another boiler. So yeah, these are all pieces of equipment that, well, the first three are pieces of equipment that the manufacturer voided the warranty on. These are only like 3 years old.
Manufacturers don't void warranties.
Yeah. And yeah, they claim that. But the next ones are the end user just got tired of the contractor coming in and not fixing it. They kept switching contractors, and eventually, I don't know that the contractors actually thought that I could figure it out, but they were looking for any excuse, I think, to make themselves not look stupid. Well, that didn't work out for them at all.
So you're talking, if we just back up a little bit, corrosion just specifically on equipment or
yes,
other component? Okay, all right.
The heat exchangers, the burners, the flue pipes. Yeah, they just totally rotten them out.
So like rust,
No.
white powder,
Yeah,
anything I'm missing?
not really any soot. None of these really have a soot problem.
Okay.
Strictly rust and the condensate white powder stuff. So the first one, back in the late 80s, I was actually working with the gas company in Cincinnati and kind of working as a consultant. I would do stuff for them. They would do stuff for me. They even sponsored some classes. So they get a call from a lady that's got a 3-year-old furnace, high efficiency, condensing, and she's on her third heat exchanger. And the manufacturer just told her after that, says, "Ma'am, we're not going to give you any more warranty. We're sorry. You can't have warranty on that one. We've already given you 2 warranties. You're washing your clothes too often." And said, "You got to stop washing in Tide." And she said, "I'm not going to wash out Tide." But so I get the call from the gas company and ask me to come look at it. I start testing it. Sure enough, I get the numbers looked sort of decent. The oxygen was good, 6%. But the 90-degree or 89-degree flue temperature seemed a little light, which didn't make sense because usually when you're under fired, your oxygen's going to be up, double digits, 10, 11, 12. And there was over 100 parts per million of CO, which is usually pretty obvious when you're under fired. So this was kind of going against the grain to a point, but then this was still pretty early in my learning experience. So I had treat lists like I didn't know what the heck I was doing, and just step by step, try to figure out what was causing it. Why was the oxygen so low? Why was the flue temperature so low? So it was a two-stage furnace. Of course, low fire, I don't think the flue temperature reached 70 degrees. But in high fire, we noticed that the inducer wasn't really didn't seem to be pulling that much. So we put a pressure gauge on the pressure switch that was used to pull in the inducer or monitor the inducer. And we found that the pressure of that going to that switch was 50% of what it was rated, which meant the inducer was running at 50% of its design capacity, which that's going to cause some venting issues. You're going to, made us know that this furnace was condensing in the primary chambers, not just the condensing chambers, but the primary chambers also.
Wow.
So I wrote down a bunch of combustion numbers and the scenario for the lady, and then I handed my report to the gas company. The gas company sent the report to the manufacturer of the furnace, and they sent her a letter back and said, "Ma'am, we're going to send you a new furnace, no charge, and it's okay if you wash again." So that was the first time that's ever happened. Manufacturer telling you whether you can wash your clothes or not. In a strange world. But that poor lady, if she hadn't called the gas company, and I know a lot of people don't expect to call your utility and get that kind of support. I think my local utility was probably the only utility in the country doing stuff like that. That was because of me. And they were grateful. So we're done with that job. That was one I did with them. I think that was the only one on corrosion I did with them. Next time I go out, I'm going to a plant with a commercial contractor. They've got a unit heater in an industrial plant. The plant prints computer ribbons for typewriters, printers, anything that used a ribbon. They printed the ribbons, and apparently the chemicals used to make print ribbons were corrosive. Well, they had a unit heater in this building. This is hanging up high, 15 feet off the floor, but it was rotting out. Almost every year they had to change it, and once again the manufacturer voided their warranty. They said, "Well, you just can't use our equipment in corrosive atmospheres." Should you even be working in those atmospheres?
Yeah. It's okay for us to work, but God forbid if you put a heating system in.
Yeah, my lungs are made of titanium.
But they had, they figured, well, maybe there's too high of a volume of bad chemicals, so they decided to bring in some more outside fresh air. And when they did that, it caused the heater to rot out even faster. And again, by this time I had realized how a draft hood dilutes the flue gas, and when you put a power venter on it, which this had, you dilute it even worse.
Uh-oh.
So when they added the extra conditioned cold air to the room, the heater just absolutely was condensing almost all the time. And of course, everybody says you had combustion air, it's going to fix it. Yeah, I fixed it all right. So again, they get frustrated. And guess who they call? They call me. And I'm thinking, I don't really think anybody thought I could do that. I wasn't sure I could do stuff like that, but I did it anyway. Because I knew I was dumb. It didn't matter what you called me when I was done. I wasn't the expert. You're getting $20 an hour and I'm getting $5. So how much could I know? So I go out again, I test it, and sure enough, I'm getting oxygen readings 7, 6, 5, 6, 5, 5, 4, 3. CO is going crazy. Now, Actually, the CO didn't go crazy. The CO pretty much stayed stable because the heater was hanging up high, so all the spillage of the flue gases was going to the floor, so it really didn't affect the combustion at all.
Hmm.
And that's the one can kind of fool you. So again, the trick to that problem was get rid of the draft hood, cover it up, put in a double acting barometric between that and the inducer, and go ahead and fire it. And sure enough, that fixed the problem. They never had another problem again. Of course, when I went in, I was kind of like the invisible man. The manufacturer didn't, or the end customer didn't know I was there, who I was, nor did I introduce myself because that wasn't my job. I didn't want to look like the hero. I wanted the contractor to look like a hero, which would bring in more business to my company. So make him dependent on me for my backup and support. So in most cases, I was never really. You could ask people who came in. Well, we don't know who he was. Had a lot of hair, we know that.
I was going to say, this pile of hair came in and
And they had this mop on his head. But that was okay. That was it made it worthwhile. Like I said, I wasn't out for glory. I was out for learning. I was out for helping. Again, it certainly benefited my company quite a bit because in less than 3 years, their business doubled. And they've been a very small company selling controls and stuff. So they went from a little over $1 million a year to over $2 million a year because of what I was doing. Of course, they didn't see me a whole lot. I was out in the field a bunch.
yeah.
So we did get that unit heater fixed up. And again, it never failed again. And so then we go on. What we got next? Makeup air heater?
Yes.
Okay.
Jim, before we go on to that one, here you had this last one you talked about with that unit heater, where you had a power venter attached to a piece of equipment with a draft hood, and we saw that the amount of dilution air was so excessive that it was lowering or diluting the exhaust flue gas temperature, so it went way down, so it was condensing. Now that was a draft hood equipment with a draft inducer. But you and I saw a situation where you had a drafted equipment, if you remember, just a few months ago, a water heater where the exiting gas temperature, flue gas temperature from the water heater was 500 degrees, and because of excessive draft,
Yeah,
you had minus 0.06. The flue gas temperature in a matter of 2 feet went from 500 to 240 before it hit the breaching where it was going up a chimney liner. If you recall, that was condensing like crazy. So even without you could have a drafted equipment with excessively high draft, you get no draft inducer, but you get the same result, correct?
yes. And I've seen anytime the draft is usually over 0.4, your dilution rate's going to be so great, the odds of having condensation are pretty high, even with natural draft. So then we get to this indirect fired makeup air heater. Again, a commercial contractor. A makeup air heater is something you put in a building when they have a lot of exhaust and you got to make up the air. And rather than just bringing in cold air, they preheat it to a makeup air heater. Now, some heaters are direct fired, which means the air and the flue gases all come into the building. And I'm not sure that's a great thing, but there's a lot of those out there. But this one was indirect with a heat exchanger, so the cold air passed across the heat exchanger, then was blown into the factory. Okay, again, in 2 years, they've gone through 2 heat exchangers. And the manufacturer voided the warranty again. So now I get the call. And the company that called me had no idea that I had been involved in similar situations prior to that. They just called me because they didn't know what else to do. And said, oh, let's call him. I never knew why they called me. It just never made sense to me. So I go out there. Sure enough, we fire up the heater, and it's 2-stage. low fire and 2-stage and flue temperature didn't even make 200 degrees. It was in the 190s.
Wow.
High fire did okay. It was like 300 plus. So there's nothing wrong with high fire. But it did have an inducer on it. An inducer just blew the flue gases straight up out the top of the heater, not more than a foot away from it. So they really weren't being discharged that far away. When we checked, again, high fire was great. When I looked closer at the heater, I noticed they had a board on it, a control board, and there was an extra slot in there for another relay. And when we got out the instructions, it said, add this relay so you have post-purge for LP. I go, what? Why post-purge for LP and not natural? There's always been this idea or theory or opinion that propane was more corrosive than natural gas.
Mm-hmm.
I don't know. I think natural gas is pretty corrosive. I've certainly seen enough of that, but and we didn't have to do any more to the propane units than we did to the natural gas units. I know a buddy of mine, it's not in the stories here, was working on a boiler, and again, it was going through flues constantly, sitting up, going through flues. We called the manufacturer. The manufacturer kept making recommendations. It kept failing. And finally, they called me. Now, they were actually customers, so they were just putting me off as long as they could, I think. So I go out there, and sure enough, it was no more than a draft hood, just doing what a draft hood does, keeping it from bending. So got rid of the draft hood. They put on the barometric, reset the burner, and good to go. I called the manufacturer and told them that it was fixed. The manufacturer said, there's no way that's going to fix it. We can't warrant that exchange. Well, they weren't warranting the way it was. So again, never again did they get called out on that heater because it never rusted out again. So again, that was just another little extra one in there. Again, I don't always count all the corrosion ones because there are plenty of them. I think that the whole idea is the different levels. It wasn't just residential. It wasn't just light commercial. It was big commercial. And that would be the next one, I think, is the larger boiler.
Yeah, you got a 2-stage boiler.
Huh?
2-stage boiler,
Okay.
fire tube.
Yeah, okay. This was in this was a uniform company. It was a pretty big plant. And I was just there doing a demo with the analyzer. That was my job at the time, just doing a demo. So I hook it up to guy's flues, and now I see his combustion and low fire is 12% oxygen, flue temperature 180. That's all CO was, 10 or 20, wasn't a big deal there. Picked the high fire, oxygen was still 10%, and the flue temperature was just barely 210. So it was still way under fire. And this thing was trying to make 180 degree water. You certainly couldn't make it with 180 degree flue temperature. And you weren't going to make a whole lot with 210. That always kind of blew me away that I saw flue temperatures colder than what they were making. And we taught that in class. And again, you sometimes get you get lucky and you find something while you're there. I was teaching at Hershey, Pennsylvania, at Milton Hershey's property. It's a school for unwanted kids and orphans and stuff. And I taught them that. Then we went out to their main power plant. First thing we tested was a boiler that was making 15-pound steam. 15-pound steam is about 300 or 250 degrees. The flue temperature was 220. And everyone in that class saw that right away. He said, that's not hot enough to make steam. I said, tell me about it. So again, you stumble on things like that, and you're made look like you're really a genius when you see it actually in the field, and you're not actually making that up. And that was some of the joys that I was able to see. These things actually performed the way I was teaching. Lousy. So again, I'm testing the boiler. I got those numbers and I looked at the plant engineer. I said, wow. I said, if you don't get this thing tuned up properly, you're going to need to retube the whole boiler and replace your flue. It's going to cost you quite a bit of money. And he just gave me this look. I go, yeah. He said, have you been here before? I said, no. Have you talked to anybody that's been here? I said, no. So we just spent $40,000 having our boiler retubed and our flue replaced.
Oh.
I said, well, get ready to do it again. Because what's wrong now? This boiler was worked on by a boiler-only company. Supposed to be the experts on that particular boiler. I knew better. They called themselves experts. He said, if I buy that analyzer, will you help tune this up right? I said, yeah, let's see what you need to do. So we checked. We turned the gas pressure up as high as we could get it. We were still way underfired. So we checked. The manufacturer's specification said you needed 12 inches of gas pressure going into the regulator. So we measured it, and it was only 10 inches.
Uh-oh.
Well, obviously, after the regulator, that's going to drop sizably, and at 10 inches, it drops a lot lower than it does at 12 inches. Well, they didn't have the gas, so they had to go to the gas company and get them to boost the gas pressure into the building. So they did get it boosted to 12 inches or 14 inches, and then they had some room to play. And sure enough, we tuned up the boiler perfectly. Low fire was close to 300 degrees, and high fire was close to 400 degrees. The way it should. Oxygen's around 3 to 5%. And once again, the boiler never failed again. And of course, the engineer called me a year later and said, my boiler is in great shape after you've been here. He says, plus our gas bill dropped about $30,000.
Whoa.
But I've loved to get the percentage of savings, which back then energy auditors were. I worked with this one group. They were getting 40% of people's savings for 7 years. Man, if I could have got that, I'd own an island in the Pacific and be retired. Didn't work out that way. Okay, so another the people you expect to be the smartest end up being some of the most knowledgeable as you can find. Again, a lot of people, I think hearsay and opinion kind of rules our industry sometimes. That's the way it always was. Okay, so we're done with that boiler. We got it fixed. And what's up next?
Yeah, the situation that was been blamed on oversized equipment down in Mobile. You were in Mobile, Alabama, doing a class.
Yes, I was. That was too much fun. I do the class. Again, I remember, I don't know if the guy ever came back to class again. But it was him and his son and some other guys. But after the class, I had about 4 or 5 hours before my flight. So they took me to one of their customers' jobs for fall cleaning. We go into the house. He goes in, opens up the furnace, and there is rust all the way up to the burners. I mean, that thing was loaded with rust. And I looked at him and his son. I said, man, I bet this thing hasn't been serviced for years. And they looked at me funny and said, it's a contract customer. We serviced it every year. I said, that's 1 year of rust? He said, oh, yeah, down here, that's normal. I said, that's not normal anywhere. But he said, oh, yeah. He says, our furnaces are all oversized. We need a 3-ton blower, and the only way you get a 3-ton blower is a 100,000 BTU furnace. And we only need 30,000 heat. So, our furnace is way oversized and short cycle. And then we got the air from the Gulf, which is salty, and salt air is very corrosive. So between that, the oversized furnace, the short cycling, yeah, it's going to corrode all our equipment. I said, no, it's not, unless you let it. And sure enough, he believed me. So he made the modifications, got rid of the draft hood, put on barometric, raised the gas pressure to fire that overfired furnace, oversized furnace, to where it belonged. Whether it was oversized or not, equipment is designed to run at its firing rate. If you're like buying a car that has a, 250 horsepower engine, but you drive slow, so you tune the engine for 100 horsepower.
Yeah.
I bet that's going to get good mileage. I think there's a law of physics that says for every load, there's one efficient force to move it. I think that's a law of physics somewhere. But so he goes through all that. That was in the fall. Next year they come back for the air conditioning service. The guy pulls the door off the furnace, looks at it, and gets concerned. He calls the homeowner over. He goes, "Man, yeah, Ronnie, what's up?" He says, "We serviced your furnace last year, and you spent a few bucks having us do some modifications and corrections." She goes, "Yeah." He said, "Why didn't you use it?" He said, "What do you mean, why didn't I use it?" "Well, why didn't you use your furnace this winter?" He said, "We did use it. We used it like we always do. It's the warmest we've ever been." He was just in shock. He didn't know where to go from there. When you see jobs like that, and then these people disappear on you, where did this company go after we did this?
Mhm.
Because we hardly heard anything from them since.
Yeah.
Is that because they don't want to go back to all those jobs that they screwed up? Admit, you don't have to admit to people. It's called new technology. We've got a means of testing and discovering things we never could before. We had X-rays, but when CAT scans came out, X-rays kind of were driving in the back seat. So our industry wasn't any different. Things progress, and you have to progress with them. Unfortunately, the people who write our rules and laws, they don't progress. They stick to the old bills. Well, that's the way it's always been.
Yeah.
We don't see any reason to change it. It's just like I look at blower charts and stuff on furnaces. They're still the same old blower charts they used to have. So many numbers are just repeats of the old numbers that don't even address the new equipment. So, and then the final job, I think, is one that's in our class field examples.
Which one's that, Jim?
Huh?
Which one's that?
Is that the veneer plant?
Yes,
Oh, yeah.
that was the veneer plant. Then this guy is going through burners and flues every 18 months. And contractors come out, make adjustments, do things in. Nothing happened. So he finally got fed up, got rid of the contractor he was using and called another one. They came out and said, "Hey, we know your problem. You got all these corrosive chemicals in this plant. We need to build a room around it, isolate it from the plant, and bring out outside air direct." And the plant engineer goes, "Oh my God, somebody actually knows what's going on here." He was ecstatic. So contractor comes in, he builds the room around it. They bring in combustion air from the roof, and they're good to go. But before the winter was over, the boiler had self-destructed in 6 months. It failed 3 times faster than it did before it was fixed. No, that was a bit embarrassing. They were really upset. Well, so was the contractor, because he was getting yelled at. So then I get the call. They tell me what's going on. I said, "Well, I know what's wrong. All you have to do is," he goes, "No. Don't want to talk about this over the phone. We need you to come in as a third party and explain to this engineer the new technology and how to fix it and get him from being all pissed off at us. So, yeah, they made me go down there and talk to the guy. We ran through the testing. What was amazing is I put my probe up inside the draft hood of the boiler while it was running, and my hand started getting cold because the center of the draft hood was right below where the flue was connected, and there's nothing but cold air coming down the flue. It was like 25 degrees outside. I'm saying, no, that should be warm air. But yeah, there was no hot air hardly at all in the draft hood. So I went over to the combustion air pipe. The temperature of the air in there was 120. But how did that room was 120? Yeah. The combustion air was the flue and the flue was the combustion air.
Wow.
Now, if you look at the picture in the book, it doesn't make sense. You know, we've been taught a flue is a flue if it's the closest pipe to the material, to the equipment.
Mm-hmm.
So it doesn't matter where the equipment is, as long as the flue is closer than any other hole, it's the flue. That one used to go over real big. I don't know how many stories I could tell. I should write a book on bad stories or bad opinions or bad, you know, things like that. It's just kind of mind-boggling that our industry, which should be some of the smartest people in the world, because we have to actually work and make our systems work.
Mm-hmm.
They can't be designed at a factory or on a computer. They have to be physically installed and physically controlled and tuned and set. So I don't know too many other industries that are that dependent on their contractors to do that. So we have to be one of the smartest groups of people there is, and yet we sit back and act like we're stupid. But then nobody's afraid to rock the boat. And that's the thing I always heard is, well, yeah, that's true, but you know, you're going to make somebody mad. I don't care. I'm going to save somebody's life. I don't care who gets mad.
Amen to that.
You know, that's, well, our local authority doesn't go along with that. Your local authority is an idiot. And they're certainly, and I've been all across the country, so I can tell you we've all run into the same crap. It wasn't just in my town, it was in other towns too.
Yeah.
Whether it was Massachusetts or whether it was Colorado or California, or I ran into the same bogus instructors everywhere. So, or code officials. I did a seminar in Ohio once. I didn't do a seminar, I had a booth at a inspectors convention, and they had it in Columbus, Ohio. I set up a CO booth, and I was going to do a quick CO, 4-hour little stint explanation. Not one of them showed up. Most of them came up to that did come to the booth and said, "Oh, we're not concerned with that. That's not our liability. We don't care about safety." And what the heck are they doing?
Yeah, everything's just by the book. They just show up, look at the picture of the manufacturer drew in the book, and if it looks like that, you're good to go.
Yeah.
And if somebody said, well, if you take this piece of equipment off of that hole, in order for that hole to work, now you got to make it smaller.
Yeah. I love that one. The smaller the hole, the better it works. It may not. Mechanically, that don't work. It may work personally, but did I say something?
No, you're good, buddy. You're good. It's all good. It's all good. You know, Jim, I had a person call me this past winter, very similar to that situation that you just talked about. You and I've talked about that boiler in the box there. where when it was a house that the homeowners just had a roof put on in the fall. And when we got some substantial snow, they started noticing a spot on the roof where the snow was melting. And all the rest of the roof, the snow just stuck. But in this one spot, that's where the snow melted first.
Huh.
And so they couldn't figure it out. Well, the contractor went back and he went up into the attic. And the spot where the snow was melting on the roof was right above where the combustion air pipe terminated to bring air from the attic area down into the CAS, the combustion appliance zone. And so, no, the air wasn't coming down from the chimney or from the attic. It was going up from the basement.
Uh-oh.
Now, I have never, in 40 years, found a combustion air going to an attic that brought air into the building. 100% of everyone I've ever tested sucks it out.
Yeah.
You know, the attic is the chimney of the house.
Yeah. Yeah. And in the wintertime, when you got stack effect going, it'll be magnified.
Yes. And yet there are some people that are pretty smart that say it can reverse.
Well, so it's like those high-low combustion air grills, right? Same thing, right? ASHRAE even admits the upper grill opening is to allow flue gases to escape.
Right. That's if your flue gets plugged.
Yeah, that's not a problem if you got to draft it.
You got to tell the flue that that hole is there.
Yeah, got to put arrows on it.
Yeah, but I remember somebody, I think it was in Minnesota, said once a flue starts venting, it'll never switch. You'll never downdraft. You never have to worry about it again. Once you get started, it'll stay drafting the rest of its life.
Huh.
Yeah.
Until the 3000 CFM exhaust fan over the oven starts running.
Exactly.
Yeah. But yeah.
Been there, done that, got the t-shirt.
But the key here is the whole reason for this podcast is corrosion is not normal. Corrosion is caused by improper venting. Now, what's causing improper venting? Could be negative pressure, could be underfiring, could be restricted things. Again, corrosion is a symptom of the problem. It's not the problem. And sometimes I get too worried about the symptom and not what's causing the symptom. Soot is not the problem. What is causing the soot is the problem.
Yep.
Sometimes you got to just drill that into people.
Yeah. It's like putting your hand on a hot burner. The pain is not the problem.
Right. Very good.
The white powder, zinc oxide, I don't know, Casey, you've seen it in your classes, but a lot of times I bring that up and, I'll say, everybody, you see this white powdery stuff showing up on your galvanized vent pipe? Yeah. Do you know what that is? No.
Yeah.
Well, it's not cocaine.
You got to be careful. If the guy's carrying a straw.
See some guy gum hits. Yeah.
Yeah.
I never did those. I heard about it. But yeah, it's, but another thing, I know Jim drilled it in, your eyes are the first tool in your service toolbox, your diagnostic toolbox.
Yes.
Oftentimes the symptoms will be right there for you to see.
Oh, yeah.
Right? Whether it's soot, the white powder, or melted grommets on top of water heater.
Yeah.
You just got to, stop with the tunnel vision. I'm just here to look at the boiler furnace water heater, and you start looking around at what's going on in the environment that you're in. Right.
Right. The measurements are the symptom. What's the problem?
Yep.
Yeah.
And many times, I got down on my hands and knees, peeked under the equipment to see what was going on. And I could see where, The burners were crooked. The pilot was too small. You could see the burn was misaligned. So burners were downhill instead of uphill. Again, you'll never get rid of visual.
Yeah.
And once you give that up, no analyzer will ever solve that problem. And you'll see. Well, you guys seen the last couple articles I wrote for the paper. What's the best analyzer?
Mm-hmm.
There isn't one.
Yeah. Well, that's the other thing too, Jim, that, after listening with you is I'm trying to get out of the habit of calling those things combustion analyzers and just calling them combustion testers.
Yes.
Because the person holding that tester is supposed to be the analyzer. That's why you need to go to a class,
Right.
get trained so you understand how to become an analyzer instead of just staring at right. You get your guys in classes. We've all heard it. Right. I'm here because I want to understand what the numbers on the analyzer is.
No.
Yeah.
Kind of like
There's a lot of numbers on there that I don't know why they're there, but
kind of like to go to a doctor and get a CAT scan. Does a CAT scan analyze what's wrong with there, or does a doctor have to figure it out?
Exactly.
So it's no different. We need to have that ability, but I think, I don't know if we're just teaching contractors that they're dumb, but they're not. I think you've got to be one of the smartest people out there if you're in our business. And somehow,
I think our industry, and it's not just limited to the HVAC, but I think it's across any of the trades. There's been you're trying to dumb down and make, plug and play, flip this dip switch, do that. There's no show your math kind of stuff anymore.
Mm-hmm.
And so, a lot of people, when they come to the class, you get guys that have been doing it 20, 30 years, will sitting after day one at the end, they're like, oh my gosh, so much of the stuff that I thought I knew today, I figured out I didn't. It's just, old wives' tales that get passed on down through all the century, right? Nice blue flame, all of that.
It certainly is my hope you guys, seeing how you're out there doing the testing now and I'm not, you'll find some things that might even be new that I've seen. I mean, a lot of it's going to be the same, but there's always somebody going to sneak something out there that's absolutely crazy.
Yeah.
And that's happened over the years. People make product, they get it approved, and it's junk. It's absolute junk. But the testing standards that we use are so bad. As I'm writing my barometric economizer report for AGA, I noticed, and I never noticed this before, they only record readings after 3 minutes. And then they're done. So they don't know what the readings are after 3 minutes.
Wow.
I know. How'd I miss that? So, I'm writing it's going to probably be the longest thing I've ever written. And I'm making it kind of funny. I said, the AGA field controls run dead. I spell fun and then I spell dead. And then I got a bunch of stupid things in there to just aggravate Mike. Deduct. You know what my deduct looks like? It's a real quack. So, okay, I think we've covered. You guys got any other questions that we might have? The students might have?
Real quick, I've had a couple of articles that have been sent to me by some folks who've attended classes where about chimney liners. And there's one out of Massachusetts and it was a commercial building. They replaced these boilers, and the new boilers they put in, they were having a problem with flue gas condensation. And so some inspector went in there and basically told them to drop liners, and they dropped liners, and they said that their flue gas condensation problem went away.
No, it didn't.
No,
No, it didn't.
but that's still something that's, I think that's going to be a dragon that we're gonna.
Yeah.
I don't know that we'll ever slay that one.
Anytime an heating inspector is smarter than you, you better get smart.
Yeah.
That's who's supposed to be smart. I just, that blows me away. And again, one of my other stories that's not in any of these or in the book is the one where, I guess it was in my court cases, where contractor put in a locking bar boiler copper pin in the people's ceramic lined chimney. And of course, it started dripping all over the floor and running on the floor, and the basement was finished. So contractor said, whoops. So they decided to put in a liner. Well, then it got worse.
Should have put in two.
So the contractor said, well, the liner actually rotted out and collapsed. So the contractor says, we're going to have to power vent it out the window. So they moved the boiler to a window on the power venter. The lady ended up in the hospital next week, CO poisoned. Now they're getting sued. But, you know, they did everything they were told to do. Does that make you innocent?
No.
Unfortunately not.
The guy that's telling you what to do, it has no clue. You know, you're putting your faith in him, you've got a problem.
Yeah, the other thing is he don't have skin in the game, right? That building inspector ain't going to get sued.
No. You got to take care of yourself. And I told people for years, I've got billions of dollars of liability on me today. How many hundreds of thousands of lives have I affected? Not enough.
I think that's one of the hardest things to convince guys nowadays, or maybe the whole time, but to, if you need to, disable and red tag, and trying to convince them that you are 100% liable when they come back and say, oh, we can't do that per our state or per our region. We're not allowed to do that. Well, nobody else is. So it's got to be you, because you're going to get, sued.
Yeah,
They're going after you.
exactly. And there's
Yeah,
no
the governor of your state isn't an HVAC contractor.
Yeah.
Neither is the legislature. So
there's no law that can prevent you from making somebody safe. Or it seems like there is, but in general rules these days. So,
yeah.
Alrighty, guys, I think we've covered it.
Awesome,
Excellent.
Jim.
Excellent.
This was good, man. Always love your stories and the things that you've ran into and share with the rest of us, man. We greatly appreciate it.
Absolutely.
Lucky as can be the people would actually not be afraid to call me out. Not necessarily that they thought it was smart, but because they were trying to prove that they weren't stupid. And the worst ones are when it only takes me 2 minutes to figure out what's wrong, and they've been there for 2 weeks.
Yeah.
I remember a boiler in downtown, a big fire tube boiler. The guy said, man, I've adjusted that boiler up and down, up and down. I changed the linkings, and I still got CO over 1,000. Well, it was a big fire tube boiler. It had an inspection plate in the back. So as soon as I walk in and it's firing, I walk to the back, look to the inspection door. I said, your burner's crooked. It's firing down one side. He walks back and looks and said, damn you. 2 weeks. Yeah. But yeah, that was between him and me, nobody else. I never squealed on my customers, no matter how dumb they were. Or, like I say, it was amusing, and they knew I knew, but it never went farther than that. I wasn't out to make them look stupid. They need my help. So, you all enjoy?
Absolutely.
Oh yeah.
Absolutely.
And this is one more egg we've been putting in our Easter basket.
Yeah, for sure.
All right, everyone. Well, that is it for today. Thanks for joining us at the High Performance HVAC podcast, and we will see you on the next one.
Thanks, everyone.
Take care.